Hi guys, this is Vineet, and in today's video we will discuss about some of the ways to capture the query performance metrics. So this will be my uh, fourth or fifth video on performance metrics or performance tuning. So I hope you have watched all the previous parts. If not, please go ahead and do so. Also guys, if you are new to this channel, please go ahead and subscribe to this channel. There is a subscribe button below this video. Click on the subscribe button and it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future performance tuning videos. I will be releasing more and more videos soon on performance metrics. So I think it would be good if you can go ahead and quickly subscribe to this channel. Let me give you 5 to 10 seconds to subscribe. Please go ahead and do so right now. So guys, I hope you have subscribed to my channel right now, and let's move ahead. So there are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your lab and test environments only. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our video, so please do share your comments, any suggestions, any requirements, any day-to-day experiences with SQL Server, any situations where the content in my video became helpful to you in any situations. You may share all those experiences with us. All right, so let me move ahead, and I have created some playlists for you to watch. Some of them are database design playlist, tables, business continuity, indexing, performance tuning, and integration services. This video will be the part of performance tuning playlist. And guys, better way to learn is to go through playlists only. So it's not good if you watch videos randomly, because I randomly release videos on various topics. So don't watch it out in that manner. If you want to gain familiarity with any particular topic, let's say for example, if you want to gain experience in performance tuning, what I would suggest is go to the performance tuning playlist and watch out all the videos in that particular playlist to gain better understanding of the performance tuning process. So far I have posted around, these stats are outdated, so I have around more than 190 videos posted on my channel. I will update these stats soon, but yeah, for now, at least just to give you a base idea, these many videos are listed against each playlist. The links for all the playlists are there in the video description area, so if you can check out the video description area, you will find all the links. Apart from that, you will find my channel page link as well in the video description area, so you can check out my channel page as well. Let's come back to today's topic. So we will be discussing on ways to capture the query performance metrics. So let's quickly go to notes. So notes are not pre-prepared, so I will be writing notes as I am teaching with this particular topic. So let's start. So in order to understand which queries we should be focused on for query twinning, we need a method to accurately measure the query performance. So first of all, one second guys, we need basically ways to measure the query performance. So first of all, we need ways to measure the query performance, and we also need to focus on which queries do we have to tune. So here we will be discussing about various ways to measure the query performance. All right, let me remove the second point. So first, what we are discussing is we need some ways to measure the query performance. In order to understand which queries we need to focus on, we need ways to measure the query's performance. Also, as we make various attempts to improve query performance, we need to be able to capture the metrics that will enable us to understand how well our improvements are working. So measure will be of various metrics. So we will capture the metrics, and these metrics will enable us to understand how well our improvements are working. These metrics will help us to understand how our improvements that we make to query are working, right? So improvements that we are making to query, make to query maybe. So whatever, so we will capture some metrics, and there are certain ways to capture the metrics, and these metrics basically will help us in understanding how our improvements are uh, working. So improvements in the sense we are making some tweaking to the queries. So we want to see whether that improvement that we have made to query has helped us in gaining any performance benefits. So that can be captured using the metrics. So that's why we need metrics. So finally, we need to be able to measure the results of our improvements. So we need to measure the results of our improvements, right? And that can be only done with the help of metrics. All right, so metric collection is a very essential process. Even if we want to see whether the changes made by us has introduced any performance benefits, we need to capture metrics before and after the changes, right? So finally, we need to be able to measure the results of our improvements in order to both validate that they worked and also start the process over again if changes have not made any performance improvements. So all right, so we will be identifying the poorly performance queries. We will capture some metrics. Let's move ahead. And if we talk about, there are a large number of mechanisms, or we can say ways to measure the query performance. All right, so there are various ways you can measure the query performance, but we are going to focus our efforts around the three. We will be talking about three ways only here, uh, because we have found these ways to be both the most accurate and the easy to implement ways. So we will be discussing three ways. I will talk about them shortly. Other mechanisms also work to capture the metrics, but we have found that these three metrics have worked best. If you just if you do choose the other mechanisms, just be consistent in what you measure, because every metric gathering tool we use varies in the values collected from all the others. So what are the various we will be discussing here? So we will be learning about three ways here. So one would be, let me name them. So we will use the dynamic management views. This is one of the ways to capture the query metrics or performance metrics, or metrics on query performance. So we will be using dynamic management views. We will be capturing the second thing is we will be capturing detailed metrics using the extended events. So we will be using extended events. That will be our second approach. First approach is using the dynamic management views. The third approach will be, we will be using the query performance metrics in the query store. We will discuss about all these three concepts soon. So stay tuned. So let me go ahead and talk about take these three ways one by one. So these are the ways to capture the query performance metrics. These three are the ways. There are large number of ways to capture the query metrics. So earlier we were talking about there are large number of ways to measure the query performance. We have listed out just three because we will be discussing in detail about just these three ways to measure the query performance. But in general, if we talk about, there are large number of ways to capture the query metrics, right? And most of them are equally accurate, but some are either easier to use, provide more complete information, or work better at scale on the larger systems. So let me give you all the ways or all the possibilities. Then we will briefly discuss about why we don't use some of the measures as others. So the possible query performance measurement method are as follows. So let's talk about the query performance measurement methods. So these are quite so many. So let me list of each of them out. Let me make this heading quickly. Let's take a heading color. Okay, so let's list out all the ways of measuring the query performance metrics. So basically, we collect client statistics. This is one of the ways. Another way is the connection properties. We check the connection properties. We use statistics, time/io. We can calculate this. We can take query time stats in the execution plan. We can take that. Next thing is we can use the query store metrics, query store performance metrics. We can use the dynamic management views that we listed out above as well. So this is also one of the methods. So dynamic management views, or simply we can say these are DMVs. And we can use the trace events as well, in which we use the SQL Server profiler to capture the query performance metrics. And the next thing we can use is extended events. So these are some of the possible ways to measure out the query performance metrics. And we are going to talk about the DMVs or dynamic management views. We will talk about query store. We will talk about the extended events. So extended events we will talk about, dynamic management views we will be talking about, and we will also talk about the query store. All right. So let's go ahead and let's discuss briefly about other ways to capture the query performance. But yeah, in detail, we will be discussing these three: query store, dynamic management view, and extended events. Rest of the items, let's take them first, and because we will be discussing them briefly. But query store, dynamic management views, and extended events, we will be discussing in detail. So let me cover all the other items here briefly. So let's start with include client statistics. So I'm just briefly discussing them here, not covering them in detail here. So what is include client statistics? Let me make this a little bit heading like. Okay, let's take this. Let's take this. So let's talk about the include client statistics. So how can we get the client statistics? Basically, what we need to do is we need to right click on the query window. Query window where we are writing the query in the SQL Server Management Studio maybe. All right. And we can select include client statistics. This is the way to include the client statistics. So let me quickly show you how you can do this where the option comes. I will just list it out. So I've triggered out the SQL Server Management Studio. And let's wait for it to open. After that, I will show you. how you can include the client statistics. So it should open out soon. Alright, as it is opened, let me connect to the default instance of SQL Server. Let me trigger a new query against the AdventureWorks database. So query is triggered. Query window is open. Now if you right click on the query window, you will see the option to include the client statistic. Let's see where is that option. So it's here, shortcut key is Shift Alt S. So if you check this option, it is now pressed, right? If you see it over here. In the toolbar, this is the window. This is the button with which you can include the client statistics. So here I'm just telling that how you can include the client statistics either by right clicking and selecting include client statistics, or the other way is to just press this button. So whenever you execute the query, you will get the client statistics as well, right? So we have just shown you how you can switch this option from the context menu. Now what it will do, it will capture the, let me go back to notes. So what it will do, including client statistics, it will capture the runtime and IO from the client where you are running the query. So basically it will provide us the runtime and the IO details where you are running the query. So basically it includes the network times, local contention for resources. I'm telling you about the information it contains, include client statistics. What all information does it contain? So it includes information about the network times, local contention of resources, and everything else, right? Possible that will negatively impact the performance management measurement. Everything else possible that will negatively impact the performance management, right? And the output of these values doesn't match in any way the output from the other methods. And because of this, we never use it because the output of this method does not match with the output from the other method, so we simply don't use it. But yeah, let me just check if I can get something. So right now, if you see, I've included the client statistics, and let me take one of the tables to fetch the data. So let me see if I can get anything. So let's select human resource dot employees. So let's do select star from human resources dot employees. Let's see if we get any stats for this query, client statistics or not. So I've executed the query. So you see a tab for client statistics. You can check it here. So you will get all the information over here. So it has given us the client execution time and whatever other processes are taking time. You can read through this. Here I will not be discussing this in detail. But yeah, it gives you information about some time statistics. It gives you some network statistics and query profile statistics regarding the number of rows returned by the select statement. It gives you details. So 290 rows are there in the table. However, it has yeah, there are 290 rows. You can see them in the results. There are 290 rows given in the client statistics. So these are just basic statistics, like number of select statement in our query is only 1, number of transactions are 0, and yeah, that's it. Under the query profile statistics, number of network statistics, if we take a look at bytes sent, byte received from the server, so 567,715 bytes received. So you can read out all this information, and this will give you just the general idea about any resource contention or whatever the execution time taken by the query. All right. So let me move ahead. here because here I will be briefly discussing these topics, not in detail. The only thing I will cover in detail is query store, dynamic management views, and extended events. So be ready for that. But yeah, here I am discussing some of the other ways briefly. All right. So now let's talk about the other way, the second way, which is the connection properties. Let's talk about it on this topic briefly. So next topic is connection properties. We can check out the connection properties. So let's see how you can do that. Let me make this heading quickly. Okay. Now let's write under this. So if we talk about the, sorry guys, okay, I'm back to the Windows. So let's talk about the connection properties. And if we talk about this method is very handy, although we do not rely on it for our primary measures. Before or even after you run the query, right click the query window in SSMS and select properties from the context menu. So what we can do in order to get the connection properties is in the query window, you can right click here and there's a properties window you can open out. So let's talk about this window. So you have just opened the properties windows from the query window context menu. You have selected properties window. So this will open the properties windows on the right hand side. And we will use this properties window with a lot of execution plans throughout our videos. And generally we will leave this window open for our upcoming videos and this videos as well. All right. So in this window, what you can find is there's a connection details. You can find it over here, right? So here is the connection detail information, right? And this details include a connection time elapsed. So you can see the information here regarding connection time elapsed. So this is giving information over here. I think it's in milliseconds, the connection time elapsed. And apart from connection time elapsed, the connection time elapsed is actually an accurate measure of query performance. So this is one of the good measure of query performance. It shows how much query has taken, how much the connection has taken, the time. So this is one of the accurate measures of query performance. While we can see query performance at the bottom of the screen in SSMS, like the status bar, we can check it out. All right. So this section, it only measures out to a second's value, not in milliseconds. But if you check over here, it shows the execution time in milliseconds as well. So but the status bar only give details till the second how much the query has taken the time to execute. It gives only up till accuracy of a seconds, but not in milliseconds. But in the connection details, you can check the connection elapsed time in milliseconds as well. So this query has taken around 874 milliseconds to complete. All right. So you can check one of the good areas to check the execution time of a query. All right. Now the values here are accurate to the milliseconds. So these are 874 milliseconds. The only problem it has is it doesn't gives us a measure of IO. So in this properties window, we cannot measure the IO, or it doesn't give any IO measures, right? So it's just not as useful as other measurements that gives us both the elapsed time and IO as well, and in some cases CPU use as well. So that is one of the drawbacks of this connection window. It just gives the one parameter, which is connection time elapsed. It doesn't give out any measures of IO, and it does not give any CPU time usage, etc. So that's why we don't generally use this method. But yeah, if you just want to see the connection time elapsed, you can check it out here. So if you forgot to enable any other data collection mechanism, this one is always available to you, which again makes very handy. So this is one of the handy methods, the connection properties window. You can check the connection elapsed time. Now let's move on to next topic, which is connection properties is done. You can check that out. I'm not writing out much details over here. All right. And the next method is the set statistics time IO. So let's move on to that. So set statistics time slash IO. Let's talk about this method. Let me make this a heading as well. We will see whether we have to write anything or not. But yeah, let's talk about this method. So this is a classic mechanism for measuring performance when tuning the queries. All right. So they give accurate. These statistics give accurate value. So if we choose to use them, we will be fine. So these statistics, if we talk about, give the accurate values. So it is fine if we are using them. All right. And we can use them by going into the options for SSMS, right clicking and choosing them from the context menu, or we can use the t=equal to set statistics time on, which makes this a handy mechanism from SQL Server Management Studio. So let's see if we can, it is saying that you can set it from the options menu. So inside tools, we have options, but yeah, we need to locate where this particular option is. So if you can give me a few minutes, let me try to locate it. So guys, I found out the area. So right click here on the query window. There are query options given over here. So inside the query options on the general page, if you go to advanced, you will see these options. If you want to get the statistics time or the statistics IO, you can check out these two options. You can turn this on if you want to get the statistics information on time and the IO. So this is the method to turn the statistics time IO to on. And let me talk about it briefly here. So we can use the query options in SSMS, and we can also use the t=equal to set the statistics time on. So let us explain why we don't use them anymore. First of all, we will get a single measurement only, and what we have found is that we get more accurate details, or we get more accurate results if we execute a query multiple times and then average the results. So in order to get the accurate results, we run the query multiple times and then average out the results. And that's very hard with this measure. Getting such kind of accurate result is very hard with this method. And we also don't get the CPU usage, so we don't use this method. Finally, if we capture both the time and the IO using this method, the IO capture can actually negatively impact the time capture as well. All right, making it less accurate. So let me repeat that again. Let me write out something. So first of all, I have told you the way to enable the statistics time IO and the statistics IO, how to enable that. And the reason why we don't use this method is you get only a single measurement, right? And in order to basically get the accurate results, we execute query multiple times and average out the results. All right, and it is very hard to get the accurate stats using this method, right? So that's why we don't use it, this method or measure, whatever you can say. And we do not get the CPU use with this method, right? And if we capture both the time and IO, so if we capture both CPU time and IO, right, using this method, the IO capture can actually negatively impact the time capture. So if our IO is here, I'm not talking about the CPU time. So let's just leave it to time here. So if we capture both the time and IO using this method, the IO we have an idea that IO capture can actually negatively impact the time capture, because if our IO devices are slow, that will eventually increase the time in order to complete the operation, right? So IO affects the time parameter as well, right? So this method is little bit less accurate, right? So, so that's why this method is little bit less accurate. So we don't use it, right? And we generally only see this on queries that are running in less than a second or even less than 100 milliseconds. However, when we most need accuracy is when we are down to tuning for those last few milliseconds. Having the accuracy upset detracts. Let's, I think, leave it. This should be enough. This method is less accurate, so we don't use it. So basically, I have generally described you how you can enable these options, and we will talk about detail in our later videos. So you please stay in tune. If you have not already subscribed, please subscribe to the channel. There's a subscribe button below this video. Please click that button out quickly if you have not already done so. So we will talk about these stats in detail in our later on videos. But yeah, we generally don't use this method because those are not very accurate. So, but yeah, we will talk about it later for sure. Now, let me talk about the next method briefly, which is the query time stats in the execution plan. Let's talk about them. So, next method is query. We check the query time stats in the execution plan of a query. Let's make this a heading. All right. Now let's talk about it. And basically, when we capture the runtime metrics with the execution plan, so you guys all know. Let me close this out. I don't want to capture the client statistics, so I've turned this option off. Now let's execute the query, and when we execute the query with an execution plan, so let me include an actual execution plan and execute it. All right, so once the query is executed, we get the execution plan tab as well if you include the actual execution plan. So we are talking about the query time stats in the execution plan. So when we capture the runtime metrics with the execution plan, which is referred to as the actual execution plan, denoted by this button, right? In SSMS, we get query runtime metrics. So starting with the SQL Server version 2016, we started getting the query runtime metrics whenever we take the actual execution plan of a query. All right, we get the query runtime metrics, including the wait statistics. So what do we get with this method is when we use the actual execution plan while running the query, what do we get? We get the query runtime metrics, right? And which also including the wait statistics as well, right? So let's see. All right, so we get two information. We get query runtime metrics and the wait statistics information as well. And these are accurate measurements and are right there as a part of the execution plan. So these are basically accurate measurements, right? and they are part of the execution plan, right? And these are accurate measurements. So we will absolutely use these, right? However, again, they only show up for the one execution. So these stats come for or only show up for one execution, right? Show for the one execution of query and making it very hard to get the averages. So basically, better way to get the accurate stats is to get the averages for the multiple query runs. This query runtime stats. Give me a moment, guys. So, guys, we were talking about that these measurements are accurate. However, these stats will only show up for one execution, and it makes us very hard to get the averages of executions. All right. Also, capturing the execution plans negatively impact the time measurement since capturing the runtime metrics along with the execution plan slows down the execution of the query. So that is also another important point. So let me write this down. Uh, when we capture the execution plans, so capturing the execution plans negatively impacts the time measurement, right? So this metric time measurement, it is affected by the when we include the execution plans in the queries. It negatively impacts the time measurement as capturing the runtime metrics, right, along with the execution plans slows down the execution of the query. So when we turn on the actual execution plan option while running the query, it generates the execution plan in the background. But however, at the same time, it negatively impacts the time measurement as basically capturing the runtime metrics along with the execution plan slows down the execution of the query. So if we capture the runtime metrics while we are also taking the execution plan, it slows down basically the execution of the query. So those time measurements will not be accurate if we include the execution plans while running the query, and we take execution plan along with the runtime metrics. All right. And for this reason, when we want accurate performance statistics, we don't capture the execution plans. So for above reason, uh, when we want accurate performance statistics, we don't usually capture the execution plans. So we don't use this methods. That's the reason why we are using just three methods out of these 8 methods. So we don't use the query time stats in the execution plan because when we include the execution plan while taking the stats, it basically slows down the query, which gives us the inaccurate results. So for this reason, whenever we want accurate performance statistics, we don't capture the execution plans. So it's a simple fact, we cannot rely on this measure all the time, right? So let's move ahead, and the next way to capture the performance measurement is performance measurement metrics is the we have done with the query time stats. So next method is the let's cover this because we are covering query store in detail later, so we are not covering it briefly here. So we will cover 3 topics in detail: query store, dynamics management view, and the extended event. So the option left is the trace events profiler. So let's talk about this. So this is one of the ways trace events available in the profiler, SQL Server profiler, we can say, right? Let me mark this as heading. Um, let mark. Let me mark it with blue color. All right. So let's talk about the trace events profiler. Right. Let's come back to the topic. Trace events profiler. So a lot of very experienced data professionals have been working with the trace events and profilers, which is basically a graphical user interface for creating and consuming the trace events data for a long time. So yeah, by trace events profiler, we are referring to the SQL Server profiler, and we have seen that lots of experienced data professionals have been busy with capturing the SQL profiler trace or trace events and profiler, which is basically a GUI for creating and consuming the trace events data for a long time. And they are also comfortable using this tool and have developed excellent skills with them as well, and basically have no intention of stopping. So most of the professional, if we see, use SQL Server profiler most of the time. We are not going to use this because of several reasons. And because of several reasons, we do not recommend use of trace events. And if we are just going with the SQL performance tuning, we would not suggest using the SQL Server profiler, and we strongly suggest don't use any of the trace profiler events or trace events. All right, and why we are saying so is because trace events are. So why don't we use the trace events using the SQL profiler? So first of all, trace events are very expensive, we can say, within the SQL Server operating system. So these are very expensive, right? So we don't recommend usage of trace events. And basically what we prefer is to, instead of using the trace events, we prefer using extended events. So if we talk about the extended events, they are built inside SQL Server, and they are not implemented separately, just like trace events. So if we can say that trace events were built uh, and implemented separately. They are not implemented within the SQL Server. So this causes them to have additional overhead, and this basically causes them to have an additional overhead. As they are available in the SQL Server Profiler application, we can enable the trace events, and they are basically expensive, and these are built and implemented outside of SQL Server. All right, so let me. So these are built and implemented separately, and basically as they are built separately, and this is basically causes the additional overhead, right? Additional overhead, we can say, in terms of memory and CPU. So basically we prefer using the extended events, which are part of SQL Server, and not the trace events, which are implemented outside of the SQL Server application. All right, so let's move ahead. And because of the way trace events capture information, they can't be filtered at capture like extended events. So another limitation of trace events is the way trace events capture information. They cannot be filtered at capture level, right? So less possibility of filtration when we use the trace events in comparison to the extended events. This means that all the resources necessary to capture an event are consumed. So basically, this means that all the resources necessary to capture an event are consumed. So all the resources which are required to capture a particular event will get consumed, right? So first of all, resources are consumed, then only the filtering, but then filtering occurs. So after all the resources are consumed for any particular event, after the consumption of all resources, at that point, filtering occurs when we use the trace events. And then, and that event is removed from the result. So the way trace event capture information, they cannot be filtered at the capture time, and which means that all the resources are consumed at the capture time, and later on the filtration happens, which will basically remove the event from the result. So this is one of the drawbacks of trace events. Now another issue is these trace events are available in the profiler GUI, right? SQL Server profiler GUI. So these trace events are captured using the SQL Server profiler GUI, right? And if we connect to the profiler GUI, so and if we connect the profiler GUI to a trace event, right, on a live server. So by live server we mean a production server. So if we connect a profiler GUI to a trace event in the live server or the production server, it consumes additional memory space, right, on that particular server, right, and uses that memory space to help consume the events in real time. So basically it utilizes the memory space on the production server if we directly use it on the production server. So it is not recommended to use the trace events or SQL profiler on the production server. So basically in order to capture the events, we basically connect the SQL Server profiler GUI to a trace event on the production server, and it consumes basically the additional memory space to capture all the events in real time. So that is one of the reasons we don't use it on the live production server. So basically when it consumes the memory, it starves your system for the resources available. So in production environment, resources are required for another operations or data operations as well. So if your SQL Server profiler trace events consume the additional memory space on a live server, that will basically uh, starves the system for the resources. So I think we should not be using the trace events. Finally, if we talk about the way we have to consume the data in trace events is not as efficient as what you can do with the live data explorer window in extended events. So extended events are more useful. So basically the way to consume data in the trace events is not as efficient as what we can do with the live data explorer window in the extended events. So let me write that down. The way we consume the data that is captured in the trace events is not as efficient as what we can do with the. So there is a live data explorer which we'll talk about soon. So there's a live data explorer window in the extended events area, which is a part of SQL Server. We can use that, so it can better capture the data in comparison to the trace events. So The way we consume data that is captured using the trace events is not as efficient as what we can do with the live data explorer window in the extended events. So extended events are more useful, and we will therefore use that method. So here we were briefly discussing about the trace events which are available in SQL Profiler. We don't generally use this method for measuring the query performance. And because of all the reasons listed above, you can go through them once. So because of all these reasons, on any system that is SQL Server 2012 or greater, I would say, we don't use the trace events to capture information. All right. Because after SQL Server 2012 or later, we have the facility of extended events, so we don't use the trace events anymore. And prior to 2012, trace events are still the preferred mechanism because we do not have extended events available prior to Server 2012 of SQL Server. So if we have SQL Server 2012 and beyond, in our case, we are using SQL Server 2022. So what we will be doing, we will be using the extended events instead of the trace events. All right. Now this topic is done. So let's come back to the original topics that we will discuss in details. Let's see how much we have captured here. Okay. Now we will talk about the dynamic management view. So we are coming back to these three topics which we will discuss in detail. So let's talk on dynamic management views. So let me write about them. Dynamic management views. Let's discuss about this. So these are our main topics. So I will highlight with the different color. So let me do that. Let's highlight it with this color. All right. So this is our main topic, and we will discuss in detail, and we will use the DMVs to measure the query performance in detail, and we will discuss this topic in detail. So let's come to dynamic management views. Let's talk about it. Give me a few minutes, guys. Let me take a 10 minutes break, then come back, then I will cover this topic. Okay, guys, let's start about the dynamic management views. So if we talk about the dynamic management view, there are a very large number of DMVs available in SQL Server, right? So there are lots of dynamic management views that are available in SQL Server. So if we limit ourselves to just talking about the DMVs associated with the query performance, there are a very still large number of DMVs left. So we will not attempt to document all of them or their uses here, right? What we will do, we will cover the core DMVs or core dynamic management views for query performance. So this is what we will cover here, and we will cover the any additional DMVs later on. But here we will just cover the DMVs that are related to queries performance. So DMVs are basically broken down into two broad categories. So what are these categories? The ones for the currently executing queries, and ones for the queries that have previously completed executing. So if we talk about the DMVs regarding the query performance, so there are basically two type of DMVs. DMVs for currently executing queries. So by currently executing queries, we mean that queries that are still in execution. There are certain DMVs associated with that, right? And the second one, DMVs are DMVs for previously completed queries. So by previously completed queries, we means that queries which have already completed their execution, and we do have DMVs available for that as well. And basically, if we talk about the DMVs for that provides the information for previously completed queries, and if we talk about this information, so the information gathered for any previously completed queries, right, is completely dependent upon the cache, because we retrieve this information from the cache, so it is cache dependent. All right. If for any reason the query has due to this, if for any reason the query has or query information has aged out of cache or been forcibly removed from cache. So in total, if the one second, guys, forcibly is the correct word. So if the query information is removed out of cache or aged out of cache, or if the query information is forcefully removed from the cache, right? All query metrics go with it. So all query metrics get removed along with it, right? So I'm talking in regards to the queries that have completed their execution. So if we want to gather any information out for those queries, we basically get it from the cache. And in cache, queries remain for a certain period of time and then get removed. So in case the information gets aged out of cache, or if the queries are forcefully removed from the cache, all metric information gets removed along with it. All right. Also, the information for any previously executed queries is aggregate only. And there is no way to differentiate between a query that ran at 2 a.m. and the same query that ran at 3 a.m. unless we use the DMVs to capture metrics at both the times. All right. So that is fine. Let's not mention about that point. Let's move ahead. So we use DMVs for query metrics frequently for several reasons. So we use DMVs for query metrics for several reasons. Let me put along some space, guys, so that it's more readable for you as well. All right. I hope you are writing down the notes along with me so that you can get better clarity. All right. So basically, what we are discussing is we use DMVs for query metrics for several reasons. And first reason is most of them are available in every single version of SQL Server, starting 2005 and up, including the AWS RDS and the Azure SQL database. All right. So why we use DMVs? So they are available starting since version 2005 till the current version. So they are available in all the versions of SQL Server. They are available in. So the reason why we use DMVs is they are available in all the versions of SQL Server starting version 2005 and up. All right. Till the current version of SQL Server. This what does this means? That we have always got a way of getting query performance metrics. So this means, which means that we have always got a way to get the query performance metrics regardless of the version we are using, right? And the second thing is why we use DMVs is we don't always have other methods enabled on the server all the times. We don't have other methods enabled on the server at all times. So that's why we prefer the DMVs. Some databases may have too heavy a load to run the query store. So query store is one of the other methods to capture the query performance information, and we will discuss that in detail later on. So why we use DMVs is that they are available in all the versions of SQL Server, and sometimes we don't have other methods enabled on the server all the times. So for example, if we say some database have too much heavy load to run the query store. So in these environments where we have had a heavy load, we cannot use the query store methods. And second thing is, if we talk about the extended events, so while extended events, if we talk about, while extended events are extremely lightweight, right? Uh, they are not free. So we don't always have them running either. All right. So that's why we prefer using the dynamic management views. All right. So we will be always to take a peek at query metrics by using the DMVs. Now let's explore how we can capture actively executing queries first. Now let's see how we can use the DMVs. So we will use the DMVs for the active executing queries. So let's cover the active executing queries. So let me type using DMVs for active executing queries. So this is my next topic. So pay some attention here, guys. Let me mark it with a separate heading color. Okay. So now what we will do, we will use DMVs for any of the actively executing queries. So DMVs are basically building blocks, and we can put them together in different ways. However, there are a few starting points which we will always fall back on. So for queries that are actively executing, the starting point of the time is, so the starting DMV that we use is for the queries that are actively executing is, we use this dynamic management view. You can note it down. It says .dm underscore execute request. So we start with this dynamic management view. Let me ignore the spelling so that you don't see the red line. So DMV. So we use sys.dm execute request first for any active executing queries. All right. Now this DMV captures a huge amount of information. So this DMV captures a huge amount of, let me ignore it. I don't know why it is. So this DMV, if we talk about the sys.dm underscore execute request, it captures a huge amount of information. All right, about any actively running queries, including the following items, I would say. So what are these items? Let's cover that. So it captures the start time when the query started to run, start time of the query. It gives us information about the command type, and basically refers to what kind of query it is. All right. Third thing is capture is plan handle, plan underscore handle. So what it refers to is, so plan handle is used to get the execution plan from the cache. So plan handle can be used. So this dynamic management views provides the information, including the start time, command type. Start time refers to when the query started. Command type refers to what kind of query it is. Plan handles refers to or pointer to a handle to a execution plan, which we can get from the query cache, plan cache. All right, let's see if any other things are provided by this DMV. So another thing is it provides SQL handle as well, apart from the plan handle. So what is SQL handle? It is used to get the T-SQL text from the cache. So it provides the text of the query and the SQL handle column. Now we can also get the blocking cache ID, or not cache ID, but the session ID. So if there are any blocks in the query execution, so if the process is, let me ignore it first. So if the process is, if your process is blocked by some other session, which session is blocking it? So this column provides this information, which session is particularly blocking our query, and it also let us know about the wait type. Let me ignore here as well. So ignore. So if the process is waiting for another process to complete, so if the process is waiting, what is it waiting on, right? So wait type column refers to that, and it also gives the total time elapsed for this particular query. So total, I would say, elapsed time it provides. So total elapsed time, if we talk about, refers to how long has the process been running, or the query execution process has been running. Next information it provides is the CPU time. It gives information on the CPU time. Let's ignore this as well. All right, so what comes under the CPU time? How much CPU has been consumed by the process? So it provides that information. The dynamic management view provides that information as well. Next information is it provides is reads, so which refers to how many reads have been done by this process. And then it talks about the writes, so how many writes have been done by this process. All right, so let me just properly format the headings here. Command type, right, plan handle, SQL handle. So this is all the information that the dynamic management view sys.dm execute request provides. Let me mark this as well. This is the DMV that we run to get this all this information about the currently running query. All right, all of the headings are marked. Now let's proceed ahead. We have talked about the information that dynamic management particular view provides. Now there's even more useful information that it collects, but we get the general idea, right? So it collects more information. I've listed out some general items. So we got the general idea, right? So to really use the DMV to pull back interesting information, we will need to combine it with multiple other or couple of other DMVs as well. So if we need some more information, we need to combine this DMV, which is assist.dm execute request, with other DMVs as well to get the more meaningful information. So another DMV, so the DMVs with which we can combine this DMV, sysdm execute request. The other DMV we can say is we can combine DMV. Let me copy that out. This one. So we can combine this DMV with other DMVs as well. So let me copy the format here with other DMVs. So the first one is you can combine it with sys dot dm underscore execute query plan. We can combine that DMV with this DMV, right? And this DMV contains basically all the execution plans, the query execution plans that are currently in the plan cache. So by using this DMV, we can, let me mark it with red color. So we can combine the sys underscore dm underscore execute request, this DMV, with, we can combine it with sys dot dm underscore execute query plan DMV. And this particular DMV contains all the execution plans that are in plan cache, right? So we can get the query execution plans if we use this DMV. All right. And the second DMV we can combine it with this. The second is sys dot dm underscore execute SQL text, and this DMV basically provides the SQL text. So which holds. Let me mark this DMV with red color. So another DMV which we can use is sys DMV execute SQL text along with this DMV. And this DMV basically holds the T-SQL batch text for the executing query that is currently being executed. So it contains the SQL text for that particular query. Now let me show you a way to combine these DMVs to retrieve the useful query metrics for currently executing queries. So let me write that down for you, not here, but in the SQL Server. So let's close this, and let's close this as well. Let me run a new query. Let's trigger it against the AdventureWorks database. So you can write this query along with me. So what we will do, first of all, let's do a select star from. Now let's take all these views. So first of our view is sys.dm execute request is the first view, right? Let's mark it as DER, right? And we are using the cross apply operator. You may read about it online, how to use the cross apply operator. And we are cross applying it to the other DMV, which is dm underscore execute query plan, which we were talking about a few minutes back. And we need to provide the argument to this DMV, so we cannot do without the argument. So what we will do, we will provide the plan handle from this dynamic management view. So we use der dot plan handle to this dynamic management view to fetch the query plan. We need to pass in the handle for that query, and we can take it as dm execution query plan, and we can take deqp, and we again cross apply it with another DMV, which is sys dot dm execute SQL text, and this also require an argument, which is the plan handle. We need to pass in plan handle here as well, right, to get the SQL text, and we can take it as dest. All right. So if we execute it, we will get some information, but we don't need all the information. So we just want useful information from these dynamic management views. So let's take dst.txt, which is the SQL text. Then we can take is the QP query plan. So let's take a query plan, and then we can take is CPU time. So der CPU time is given by der, and the dot logical reads. Let's take that, and Let's take some writes. So dr writes. So let me take this query. So it is showing me some my own query. It is showing me over here, and it is showing the query plan as well, and CPU time, logical reads and writes for the currently executing query, which is currently I'm executing this, so it is giving the execution plan for this query. So right now there are no queries executing in our environments. That's why it has given us this query, and we can get much more sophisticated with the queries against these DMVs. So that you are returning individual statements rather than entire batches. So we will show you some more sophisticated ways later on. So filtering out the session ID for the query itself and more. We'll talk about it later. So this is enough to get you started. So we have talked about the queries that are actively executing. We use these three DMVs to get the information for any actively executing queries. Let me save this query. So let me save it with information for actively executing queries. Now let's come to another topic, which is so far we have talked about the using the DMVs for actively executing queries. Now let's talk about using the DMVs for previously executed queries. So using DMVs for previously executed queries. So they and this is these are used for the queries that have already completed their execution. So let me quickly go ahead and mark it with the color, proper color. So not a proper color here. Let me select another one. All right, so let's talk about using DMVs for previously executed queries. Let's see how much we have recorded. Okay, let's carry on. So let's talk about the previously executed queries. Now to see the queries that have been previously executed, we have a number of choices on where to start. So the most common thing is to use the there's a particular. So to start with, we use sys.dm underscore execute underscore query stats, and this is the DMV for the queries that have already done their execution. So let me mark it with some different color and basically ignore the spellings. Okay, so please remember this DMV. So we use sys.dm execute query stats for any queries that are already executed. We start with here. And this DMV has a lot of uh, information or interesting information when it comes to query performance statistics. So what information does it have? Let me write some of the information down. So it provides the SQL handle, so which is basically used to get the T-SQL for the batch. And the second thing is, let me alongside mark it with colors, so ignore it and color it. All right. So second item this DMV provides is the plan handle. All right. So plan handle is used to we talked about it earlier as well. So plan handle is used to get the execution plan for the query. All right. So next information it provides is the last execution time. So this is only available for the query that has already executed. So last execution time field is only available for the queries that have already completed their execution. So this refers to the last time this query was executed. All right. And we can check the execution count as well. So which basically refers to how many times has the query been executed. So a particular query, how many times does it executed in the system? This parameter, execution count, provides information about that. And let's talk about the total logical reads. So this DMV provides the total information on total logical reads for a particular query that has completed their execution. So how many reads in the last run of the query? It refers to that total logical reads. And it also provides the average stats, which is given by the average logical reads, and which basically refers to the average reads across all the runs of the queries. So earlier we were talking about the averages. So here we get the average stats for multiple runs of the query, and those are very useful. So let me ignore it and properly give the color to the heading. Just a few minutes, guys. Bear with me. So ignore, let's mark it with the color, proper color. So this TMV, system execute query stats, provides all this information in the form of columns, and the description is given here for all the columns we get. All right, so I hope you have gone through this description and have written the notes as well. All right. Now, all these are just simple stats I've referred here. So it provides much more information than these columns. We can also see the total, average, minimum, and maximum on a variety of measures, including time, CPU, reads, and writes. So I have not written those. So you will get those as well. And before we want to combine this with the other DMVs to put together a more complete picture, let me show you a query to use this particular DMV. And we can combine it with other DMV, including the sys.dm execute query plan and sys. So in the previous query, there was one issue. So we don't pass the plan handle, but instead we pass the SQL handle to this DMV, right? So earlier we had passed on the plan handle, but we should be passing the SQL handle. All right, so let me save it. And let me write the query using a DMV for the queries that are already executed. So along with me, you can write that. So let's do a select star from, let's use this DM, which is sys.dm underscore execute query stats. So sys.dm execute query stats. So let's take it as DEQS, and let's cross apply this DMV with sys dot. We could have copied out the text from earlier uh, query as well, but yeah, let me just go ahead and quickly write it. So we can join it with another DMV, which is this, and this takes argument, and it takes the DQS dot. It takes the plan handle. So let's put the plan handle as the argument, and let's take it as DQP, or dynamic execution query plan. Let's cross apply it again with the sys.dm underscore execute SQL text to get the SQL text, and we need to pass in the SQL handle. So DQS, let's pass in the SQL handle, and let's take it as DEST. Now let's execute the query. So it gives out much more information, and we don't need all the columns. Let's select just the meaningful columns out of this information. So first let's select dst dot the text, which is the query text, and then we can take dqp dot query plan, and then we can take the qs dot maybe execution count, maybe we can take, which gives the execution count for a particular query. And let's take the qs dot minimum logical writes, reads maybe, and then writes. EQS dot minimum logical, let's take writes. Let's take another information, DQS dot maybe total logical reads. We can take total logical reads, and we can take total elapsed time as well. Total elapsed, so it's DQS, sorry guys. Total elapsed time we can take, and last column we are taking is DQS dot last elapsed time. All right, so this much is sufficient. So let's take this information about out. So we got this information, right? So first is the column is giving out the query text, whatever the query is executed in the past, and their query plan as well. We can click on it to get the query plan for the previous executed queries. So this provides the historical information, right? And let's save out this query. So we should save it with information for already executed queries. We can get it through these dynamic management views. So views are here. You can note down this query. We'll shortly show you how to get the information for actual queries. So this is just a template to get the information. So this is one of the possible ways to look at the data, and we can add the where clause to search for a particular text and so much more. And there are also specific DMVs for particular object types. So other DMVs, let me talk about them. So apart from these DMVs, which are the query plan and the SQL text, there are other DMVs available as well. So let me talk about them. So there are more DMVs available for particular object types. So some of the DMVs, let me talk about them. So one of the DMVs is sys.dm underscore execute procedure stats, which gives stats about any of the stored procedures that are executing. So let me define it briefly. So it operates similarly to, sorry guys. So it operates similarly to the sys.dm underscore execute query stats. So execution manner is similar, but it executes for stored procedures only. All right. So let me ignore it. So this is one of the another DMVs which are being used and basically used for stored procedures only. All right. So another DMVs which are here is sys.dm execute function stats, and we can execute it for any of the functions. And uh, this is basically the same idea, but for any user defined functions, we could say. So we can execute this DMV for any user defined functions. Later on, we will show the use. For now, let me just mention it about this DMV. All right, another DMV which we can use is sys.dm underscore execute trigger stats, and similarly this can be used for aggregating information about so this can be used for aggregating information about the trigger performance. All right, so yep, these are some of them. Let me properly ignore it and color the heading so it's more viewable, aesthetic. All right. Now, between all these DMVs, we can get the information we need to show aggregated query performance for the queries currently in cache. And shortly, we will show you some additional example queries using the DMVs. So stay in tune for upcoming videos. So here we have discussed some of the DMVs to get the information about already executing queries or the queries which are already executed in the system. So previously executed information, we can get information out through some DMVs, and we have discussed these DMVs and the information it provides. We have talked about some of the other DMVs as well. Now the next topic will be query store. So it's a short topic. Let me cover it over here. So guys, this will be the part one of this video. So we will cover the extended events in the next part of this video. So let me quickly cover the query store. We are just covering it over here briefly. So let me mark it with a heading, just a blue heading. All right. So let's talk about query store. So query store was introduced in, so this was introduced in SQL Server 2016, right? First point is this, and has gone through number of updates in each release since then. And the core behavior hasn't changed since the initial release. Query store is enabled on database by database basis. So let me mark this point. So query store is enabled per database or on a database by database basis. We can enable it for a particular database, right? So it can be turned on for certain databases or it can be turned off for certain databases. And what it will do is it will capture the query metrics in an aggregated fashion. All right, so it keeps the query metrics in an aggregated fashion and stores them within the database where it is enabled. So it basically it captures the query metrics and hold it within a certain database if it is enabled on a particular database. All right. And the aggregations are broken up by time, which is the default is 60 minutes. So this aggregated data, all the aggregations, if we talk about, are broken up by time, um, which by default is 60 minutes, guys, and which makes it possible to compare the performance over time. So it keeps track every 60 minutes so that we can compare the performance and not simply relying on aggregation. So we can compare the two query plans or performance plans using the query store. And we will cover query store in more detail later in our upcoming videos. So guys, stay in tune. If you have not already subscribed to this channel, please go ahead and subscribe immediately. There's a subscribe button below this video through which you can subscribe. Let me give you 5 to 10 seconds to subscribe. After that, I will continue. So guys, I hope you have subscribed by now if you're new to this channel. Alright, as these videos are very useful for you. Now we will cover query store in more detail later on because there is so much information to cover which cannot be covered in this video. So this is one of the three principal methods for capturing the query metrics. So we will be using the DMVs, we will be using the query store, and we will be using the extended events. So in our next video, we will be talking about the extended events. Let me just write that. We will talk about extended events, right? Which is the another method to capture the query performance. How to color this? Okay. So we have colored it. So in next video, we will cover the extended events. So guys, I hope you have already subscribed to this channel. I will be releasing this video out soon on the extended events. So stay in tune and have a look out for the next video. And I hope guys you are liking my videos on performance tuning. Please go out through the performance tuning playlist. There are lots of videos inside that playlist to get gain a better clarity on this particular domain, the performance tuning. So guys, I hope you like this video, and if you have really liked this video, please click on the like button below this video. And also please share in your comments your suggestion, your requirements, and do share us your experiences with SQL Server. And you may also let us know about the situation where content mentioned in our videos have helped you in some way. All right, and I thank you so much for your time on this video, guys. And if you have a good network of friends, please ask them to subscribe to my channel in case you feel my videos are useful for them. And if my channel provides useful information that can benefit your friend's life, so ask them to subscribe to my channel. And also you can share my YouTube videos with them via the share button on YouTube. You can easily share my videos with them. So guys, I hope you like this video, and thank you so much for your time that you've spent on this video, and have a wonderful day ahead, guys. Thanks.